Okay, so we are doing module 3.7, division of polynomials. You will notice that we are doing the modules a little bit out of order. I think it's going to make for more coherent learning for all of you, so we will typically, after this, be back in order, but since we just did adding, subtracting, multiplying polynomials, we're going to move on to division. Okay, so the first thing is dividing a polynomial by a monomial. Remember that poly means many, and monomial means one. So that's when you have a polynomial with several terms divided by a single term. So one of the ways that you can do this, what you're really doing is making sure that you divide everything in the polynomial by that divisor. So an easy way to do that is to turn each into a fraction, making sure that that divisor is in the denominator of each of those fractions. So if I do that, 20 divided by 4 would be 5. I have more x's on the top than I do on the bottom by 1. So 20x squared divided by 4x would be 5x. And 12x divided by 4x would be 3. So if I do that, my answer would be 5x plus 3. Okay. Let's see, you're going to do the same thing here. Now, you don't have to do it this way. You could actually do these as a long division problem if you wanted to. 18n squared plus 6n. I'm giving you different options to do this. Okay, so 3 goes into 18 6 times, n goes into n squared once. 18n squared, subtract that. 0, bring down the 6n. 3n goes into 6n twice. 6n, subtract, and you have no remainder. So your answer is 6n plus 2. Of course, how can you check these answers to make sure that you have them right? You can multiply your answer by the divisor to see if you in fact get that answer right. I'll go ahead and do this one box method, which you learned on Monday and Tuesday. That would give us 18n squared and 6n, which is in fact what we started with here. Okay, go ahead and do number 3 and 4, and then come back and check your work. I'd like you to recognize also that an equation such as this, a problem such as this, can also be written in fraction form because we know that the line in a fraction means divided by. So you're essentially doing this. You're dividing everything by that 2b. Okay? So 1, this is like a 1. 1b divided by 1b cubed divided by 2b would be 1/2 b squared. Negative 12 divided by 2 is negative 6. B squared divided by b is b. 6 divided by 2 is 3, and b divided by b is just 1. So our answer is 1/2 b squared minus 6b plus 3. Dividing everything by 4r. 8 divided by 4 is 2. R fourth divided by r is r third, r to the third. 4 divided by 4 is just 1. R squared divided by r is just r. Negative 20 divided by 4 is negative 5. R divided by r is just 1. Okay? Last one, you'll see that this is written differently over one single denominator, but it still means that each one of those is being divided by the 6pr. These two expressions are definitely equal to one another. Now you can just go piece by piece. 12 divided by 6 is 2. P cubed divided by p is p squared. R squared divided by r is r. Plus 18 divided by 6 is 3. P squared divided by p is p. R divided by r is just 1, so we can just leave that alone. 6pr divided by 6pr. Anything divided by itself is always 1. Okay? Lastly, dividing all of those by 9q. Sorry about that. It was a q, sad q. 6 divided by 9 reduces to 2/3. Q squared divided by q is just q. Negative 18 divided by 9 is negative 2. Q divided by q is just q. Or excuse me, q divided by q is 1. Negative 9 divided by 9 is negative 1, and q divided by q is 1. So these two are similar terms. They are constants, so I can put them together. So you get 2/3 of q minus 3. Please recognize that because these were both q's, I could have simplified those terms first before I started dividing. And if I double check that, negative 27q divided by 9q would give us negative 3, so that's correct. Okay, easy enough. So next we'll move on to long division. So long division is something you've been doing since roughly, what, 3rd grade. Now we're just applying that to polynomials, okay? So the degree of a polynomial, like you learned on Monday and Tuesday, the degree of a polynomial is the largest exponent that it has. So if I give you 4x to the 5th minus 3x to the 3rd plus 12x squared minus 1, okay? The largest exponent that we have there is a 5. It's not the largest coefficient. That does not matter. The largest exponent we have is a 5. So this is a 5th degree polynomial, okay? Or has a degree of 5. Okay? The leading coefficient we now know is that first number when it's listed in descending order from our largest exponent to our smallest, which you should be doing with all polynomials at all times. The leading coefficient is going to be exactly what it says, that leading number in the front of our polynomial. So, in this case, our leading coefficient for this, the leading coefficient is 4. Okay? Just as in whole number problems, long division is a method of finding a factor or a divisor. We talked about how factors and divisors are synonymous terms. They mean the same thing. If you think about different factors of 48, right, you've got 16 and 3, 2 and 24, 1 and 48, 6 and 8. All of those can be turned into a divisor, 48 divided by 6. This is a divisor. It's also a factor. They're synonymous terms. Long division and synthetic division are utilized when we're trying to divide a polynomial by another polynomial. Most of the time, that's going to be a binomial, okay? And you're really going to do it similarly to how you do long division. Let's think about how you do long division. If I give you 643 divided by 7, okay? The first thing that you do is that you look and see, can I put it into the first term? I can't. Can I put it into the second term? Can I put it into 64? Yes, I can. That's 63. Then what do? We subtract to see how many of those were taken away. Then we bring the next number down. So that's a 1. We do the same thing again, and on, right? So that's going to give you a, let's see, that goes in 8 times, and you can continue on and on, correct? So we're really doing the same thing with long division. The only difference is the important number that you're looking at, these are the directions, is this indicator right here. That's what we worry about with long division. So you're going to make sure that the polynomial is written in descending order. If any terms are missing, you're going to fill them in. So for example, back in our example up here, we're missing an x to the 4th. We're missing an x. So we would actually need to put in 0x to the 4th and 0x for that. We need to have a space holder for each of those. Okay. So then you're going to divide. You're going to put this outside our, let's just start with this one. So we're going to have x plus 2 on the outside, and x cubed plus 2x squared minus x, we can put 1x minus 2. The only two things that I'm looking at first, the first time, are my first term and the first part of that binomial. That's all I'm worried about. I'm not going to worry about the 2 right now, okay? And all I'm asking is, how many times does x go into x to the 3rd? Meaning, x to the 3rd divided by x equals what? And of course I know that that's x squared. So that's what you want to check. X times x squared gives you x to the 3rd. You always want that first term, every single step, to cancel out. So your goal is every step is for the first term to cancel out. Okay? So now you're going to use distributive property and multiply what you just decided would cancel this out by the entire binomial. So what you're doing is x squared times x plus 2. So x squared times x is x cubed. 2 times 2x squared is 2x squared. Now, think about what we did back here with our regular numbers. What was our second step that we did here with the 63? We knew that 7 went into 64 9 times. That's 63. Then we subtracted that amount. The only difference now is that you have a whole term of things that you have to subtract. This entire thing is being subtracted, which means we do what with the signs? You subtract a polynomial, it's the same as multiplying everything by -1, so it flips your signs. So what I would do is just put them right in there. This first term should always be canceling out, always without exception. So x cubed minus x cubed goes away. What's 2x squared minus 2x squared? This, in this case, this also happened to go away, okay? How many times, now you're going to ask yourself the question again, how many times does x go into 0x squared? There is nothing there, so we have 0x. Now we're going to bring down the next term, okay? Now you're going to ask yourself the same question again, because these canceled out. How many times does x go into negative 1x? That goes in -1. Now you're going to use distributive property, multiplying -1 times x plus 2. So we should bring down both. We need to multiply out both. -1 times x is -1x. 2 times -1 is -2. Now we're going to reverse the signs because we're subtracting, which means that we are changing both of those signs. So that changes it to 1 and 1. So -1x plus 1x gives you 0, -2 plus 2 gives you 0, those both cancel out, means you have no remainder. If your resulting answer there is 0, then that means you have no remainder. So your answer is x squared minus 1. Now, if you get to this point, and this is still factorable, you must factor that out. Must factor if possible. And this actually is factorable because we have a perfect square and a perfect square, no middle term, and a negative sign in between, which means we have a positive and a negative. Square root of x squared is x. Square root of 1 is 1. So this is completely divided out. Okay? Let's go ahead and do the practice problem. So on the outside of our equation goes our divisor, the 2x plus 1. Now, the problem with our polynomial there is that's set up in descending order. And you have largest exponent down to smallest exponent. Currently, it's not there. We've got our x cubed here, x squared is way over here, x, and then our constant. So we need to rearrange that so that we have largest exponent down to smallest exponent. Okay, so we need to have 12x cubed plus 20x squared plus 11x plus 2. Now you're going to do exactly the same process. You are only looking at 2x and 12x cubed. That's all we're concerned about. So how many times does 2 go into 12? Correct, 6. How many times does x go into x cubed? That would be x squared. So 6x squared. Double check that. 6 times 2 is 12. X squared times x is x cubed. Before you even start doing distributive property, check your answer there. Now you're going to do distributive property, multiplying 6x squared by this entire binomial on the outside. So 6 times 2 is 12. X squared times x is x cubed. 1 times 6x squared is just 6x squared. If that's positive, leave it like this. Now that we need to subtract, we know we have to flip both of those signs. So this term should always cancel out. Whatever you're trying to put in, you should always be dividing that by a number that you know will cancel this out. 20 minus 6 is 14, x squared. Bring your next term down. Now do the same thing again. You're only looking at 2x and 14x squared. So 2 goes into 14 7 times, x goes into x squared x. So we should have 7x. Now use distributive property, multiplying 7x times 2x plus 1. 7 times 2 is 14. X times x is x squared. 7x times 1 is 7x. Everything's positive. Now I need to reverse the signs because I'm subtracting. So 11 minus 7x is 4x. Now you're going to bring down the 2. Repeat the step again. You're going to keep repeating these steps until you are done. Okay? 2x goes into 4x. How many times? It goes in twice. 2x times 2 is 4x. 2 times 1 is 2. Reverse your signs. Cancels out, again, no remainder. If you were to have a remainder, say this one we had a remainder of 3. Remainder of 3. You would simply write that at the end, plus 3 over whatever your divisor is. Okay, that's how that would be annotated. But since it's not, that is your answer right there. You will have a worksheet in class on long division and synthetic division to give you more practice at this. Okay? All right, on to synthetic division. So synthetic division sounds like it would be complicated, but in all actuality, it's a much quicker way to do division than long division. The main reason is because you don't have to keep rewriting your variable the entire time. Okay, but synthetic division has some specific rules that you have to go by. So synthetic can only be used when the leading coefficient of the divisor is 1 and the degree is 1. So, for example, you can divide a monomial by x plus 7 or x minus a half, but not by x squared plus 1 or 7x minus 1. If the leading coefficient, that number out in front, is not a 1, the entire polynomial must be divided by the leading coefficient first. So let's take 3x plus 1. Or sorry, 3x minus 1. This is currently not 1. I need that number to be 1. So whatever I have to divide out of that to get it to be 1, which would be 3, that would change to x minus 1/3. They're equivalent terms, but I need it in the format where the coefficient is 1. Okay? Same with 5x plus 2. Currently, this is not a 1. I need it to be a 1. So I have to divide both of those out. So that would give me x plus 2/5. Now that's a leading coefficient of 1. It's also a degree of 1. I'm good to go. Okay. So synthetic division kind of has an odd form to it to begin with. First, you're going to set the denominator equal to 0 to find the number to put in the division box. So what synthetic division looks like is that, oh, this should be an x squared. Sorry about that. To the third and to the fourth. I missed all my superscripts on these, didn't I? That's okay. So, whatever makes this equal 0. So you're going to set x equals 0, so that's the opposite, so x equals negative 2. So it's always the opposite of that number. So if it's x plus 2, you're going to put in a little box out here, negative 2. Why is it negative, you ask? Well, let's go back to long division. Once you did distributive property down here, what was our next step? We subtracted, right? So what happens is, because we are making in synthetic division, our divisor number on the outside, we're flipping its sign, we're building in the subtraction. Because we're always doing the opposite. That's what we're doing there. Okay, so your next step is that you're going to make sure that your polynomial is in descending order. And this one is 3x squared plus 7x plus 2. So it's in descending order, I'm good. And what you're going to do is just write down the coefficients. So in this case, we have a 3, 7, and a 2. Okay? Draw an arrow. Leave yourself some space, just like that. This is the setup for synthetic division. Looks very bizarre, I know. You'll see in a moment why it works. So, first thing you're going to do is pull down this first number. So 3 is our first number. the next step, and I'll do it in different color for you so it differentiates a little bit. You're going to multiply the divisor times that number and put it right below the number in your second column. So negative 2 times 3 is negative 6, and you're going to put it right over there below the 7. Then you're going to add those together. Okay, so 7 minus 6 is 1. You're going to keep repeating that process until you get done. So you're going to multiply 1 times negative 2 and put that answer here. So 1 times negative 2 is negative 2. 2 minus 2 is 0. If this number at the end is a 0, that means there is no remainder. That is what that means. Okay. Now, when you rewrite your answer, you're going, well, that's a 3 and a 1, Ms. V, so I don't know what that means. Whatever your term was that you began with, your largest, your degree, your answer is going to start a degree lower than that, because what we actually did was divided 3x squared divided by an x. So 3x squared divided by x would just give us 3x. So you're always starting one term lower than what the original polynomial was. Okay? So in this case, it started as an x squared. So this is going to be 3x plus 1. So our answer is 3x plus 1. I know, seems much easier than long division. If you notice, there are no x's going on here until the very, very end, which is really the nice part about it. It's much cleaner, much quicker. Okay. Oh, this is, wow, divided by x plus 5. Sorry about that. Lots of typos on this one. That's not good. Okay. So let's do practice number 1. So ask yourself, what number should go out here? Here's your divisor. Think back here. What did we do? Do we put the same number or the opposite number? It's always going to be the opposite. So we're going to put negative 5 out here. Make sure that your polynomial is listed largest degree to smallest. So 2, 1, and 0. We can do that. And then list out your coefficients. Bring the first one down. And then you're ready to start. So we're going to go 2 times negative 5 is negative 10. 7 minus 10 is negative 3. Negative 5 times negative 3 is 15. Negative 15 plus 15 is 0. That tells you no remainder. Okay. Now because we started with an x squared, our answer here is going to be an x, so our answer is 2x minus 3. How can you check your work? How can you check your work and make sure that you have the answer correct? You can always take your answer, multiply it back to your x plus 5, and make sure that you end up with this answer that you see here. We'll do that in just 1 minute. Okay, so let's do practice 3 and practice 4. You can go ahead and try this on your own. Really apologize for my typos here. So that should be 3x squared plus 4x minus x to the 4th minus 2x to the 3rd minus 4 divided by x plus 2. So remember, first you need to get these in order. Go ahead and try number 3 and then come back and check your work. So the first thing I needed to do was put this in numerical order, which would have been negative x to the 4th plus 2x, or sorry, minus 2x cubed plus 3x squared plus 4x minus 4. So on the outside, in the divider box, I'm going to put the opposite of 2, which is negative 2. My coefficients across. Oh, there's the other thing you need to check for. Do you have a space maintained for every exponent? So we have 4, 3, 2. That's like a 1. That's like an x to the 0. 4, 3, 2, 1, 0. Yes, I'm good to go. So negative 1, negative 2, 3, 4, negative 4. Drop the first number down. It also takes a lot less room than long division and a lot less effort than long division. So it may become your preferred way, hopefully. Negative 1 times negative 2 is 2. Negative 2 plus 2 is 0. 0 times negative 2 is 0. 3 plus 0 is 3. 3 times negative 2 is negative 6. 4 minus 6 is negative 2. Negative 2 times negative 2 is 4. Negative 4 plus 4 is 0. Again, there is no remainder. That is not going to happen all the time. Just to forewarn you of what's coming in the next section. Okay, so because this began with an x to the fourth, our answer is going to be 1 degree less than that. So it's going to be negative x cubed plus 0x squared. You can put the x squared if you'd like it to in there, but you don't have to. 3x minus 2. Okay. And lastly, go ahead and do practice number 4. I'm going to tell you that make sure each of your exponents has a space here. So go ahead and do practice number 4 on your own. Come back and check your work. Okay, so my divisor is going to be -1 since it's the opposite of +1. I have a 6, 5. I don't have a 4, so that's like 0x to the fourth. I do have a third power to the third power. I don't have an x squared power, and I don't have an x power. So now I've got them all accounted for. 6, 5, 4, 3, 2, 1, and 0. So now I have them all. I need to make sure I put them in the right order. So my sixth coefficient is 1, fifth is 4, fourth is 0, third is -2, x squared is 0, x is 0, and our constant is 7. So let's make sure we've got them all. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Good. Bring that down. Line straight across. -1. Now you're multiplying and adding. Multiplying and adding. That's all you're doing. 1 times -1 is -1. 4 minus 1 is 3. 3 times -1 is -3. 0 minus 3 is -3. -3 times -1 is 3. -2 plus 3 is 1. 1 times -1 is -1. 0 times -1 is -1. -1 times -1 is 1. 0 plus 1 is 1. 1 times -1 is -1. 7 minus 1 is 6. This is not a 0. That means that is a remainder. Okay, and I'll show you how to write that. Since we began with x to the 6th, what's our new term going to be? Our first exponent. It's going to be 1 less than that. Excuse me. So your answer is going to be x to the 5th plus 3x to the 4th minus 3x to the 3rd plus x squared minus x plus 1 plus 6 goes on the top and our divisor goes on the bottom, x plus 1. If you have a remainder, you write it as the numerator of a fraction with your original divisor as the denominator. Okay? Again, much more practice in class, so we'll be able to do that. One of the great uses for for synthetic division is be able to use remainder theorem. This tells us, it actually gives us points on a graph, which is the best application of it, and able for us to figure out the ending point of a situation, even if we're given a long, complicated polynomial. Okay? So the remainder theorem. The remainder theorem states that if a polynomial is divided by some divisor, say x minus 5, x plus 2, then the remainder is a function of that divisor. Simply put, the remainder theorem says if you want to evaluate a polynomial at some value, you want to plug in any value, then the answer is the remainder. Okay? So, just rewriting that polynomial for you. Use synthetic division and the remainder theorem to find f of 3 if f of x equals x cubed minus 5x squared plus 3x plus 7. Okay? So first we're going to use the synthetic division for that. Well, what that means is, this means if our solution was x, that means that x equals 3. When you have your factors in your solution, so say we are multiplying in the synthetic, we're always doing the opposite, right? So for example, our last one that we did was x plus 1. If my factor is x plus 1, what do you know about the solution? Is it the same or the opposite of that? The solution is x equals 1. Okay. This is being used as a solution. Does that solution, if I use that number, what is my answer here? So you're going to put that number on the outside in the divisor box. Okay. Recognize the difference between x equals the number and x plus 1 is the factor of the equation. Now check that your polynomial has all terms accounted for, 3, 2, 1, 0, yes. And our coefficients then are 1, -5, 3, and 7. First one down, line across, and go. So 3 times 1 is 3, negative 5 plus 3 is negative 2, 3 times negative 2 is negative 6, 3 minus 6 is negative 3, 3 minus 3 is negative 9, 7 minus 9 is negative 2. So is there a remainder here? Yes, there is. A remainder is negative 2. So what that says is for the function f, for this function, when f equals 3, our answer is going to be negative 2. That's what the remainder theorem says. So if we have a situation where this is useful is if we have a situation said when we plug in 3 people to the widget machine, given this function, what is our output going to be for that? And the output for that would be negative 2. Okay. So, and let's just check that, because you can also do something called synthetic substitution, which means that you're substituting 3 into all of this, and you should get negative 2 as an answer. So let's check that and see if that actually happens. So let's check to see if that's really the case. So let's take our original equation, x cubed minus 5x squared plus 3x plus 7. And let's substitute 3 in and see what our answer is. So that'd be 3 cubed minus 5 times 3 squared plus 3 times 3 plus 7, which would be 27 minus 45 plus 9 plus 7. 16 plus 27 is 43 minus 45 does give us negative 2. Isn't this amount of work a lot nicer than this amount of work? So that does check out to be true. So what I'd like you to do for each of these down here is that you're going to use synthetic division to divide all of these and see, using the remainder theorem, what your solutions would be to that. Okay, so go ahead and do that for your practice down below, and then come back and check your work with mine. Okay, so all I did was set up all of my synthetic divisions. They're all exactly the same setup. The only difference is what's being put out in the front. All of these, since they're x minus 1, x minus 2, x minus 3, I'm going to have 1, 2, 3 in my divider boxes. And these are x plus 1, x plus 2, x plus 3. So I'm going to have negative 1, negative 2, negative 3. Now I'm just going to rip through them. So 1 times 2 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 17 plus 5 is negative 12. 1 times negative 12 is negative 12. Negative 30 minus 12 is negative 42. So by a remainder theorem, what I know is that f of 1 equals negative 42. That's what remainder theorem tells me. If there is a remainder for this solution, when I plug this solution into this function, the resulting answer will be equal to that remainder. Okay, 2 times 2 is 4. 3 plus 4 is 7, excuse me. 2 times 7 is 14. Negative 17 plus 14 is negative 3. 2 times negative 3 is negative 6. Negative 30 minus 6 is negative 36. That is my remainder. So for this function, when x equals 2, I get an answer of negative 36. Moving on, 3 times 2 is 6. 3 plus 6 is 9. 9 times 3 is 27. Negative 17 plus 27 is 10. 10 times 3 is 30. Oh, negative 30 plus 30 is 0. This tells me for this function, when f is 3, I have a resulting answer of 0. Okay, which tells me this will be one of my solutions. Or one of my zeros. That will come back to us when we are graphing. Okay, so this is a good one. These back here tell me those are not solutions. 2 is not a solution. Wherever x equals 2 for this function is not a solution. This is not a solution. They are solutions when they are zeros, when they have a y value of 0, which means they sit on the x-axis. Okay, so let's knock out the bottom row. 2 times negative 1 is negative 2. 3 minus 2 is 1. 1 times negative 1 is negative 1. Negative 17 and negative 1 is negative 18. Negative 1 times negative 18 is 18. Negative 30 plus 18 is negative 12. So f of negative 1 equals negative 12. Okay. x plus 2, so I have negative 2 in the box. 2 times negative 2 is negative 4. 3 minus 4 is negative 1. Negative 2 times negative 1 is 2. Negative 17 times 2 is negative 15. Negative 2 times negative 15 is 30. Negative 30 plus 30 is 0. This is going to be a solution for us, or a 0. 0, or a root. Those are all interchangeable terms when we start graphing. So f of negative 2 equals 0. It's a really quick way to find your zeros for a graph. Last one. 2 times negative 3 is negative 6. 3 plus negative 6 is negative 3. Negative 3 times negative 3 is 9. Negative 17 plus 9 is negative 8. Negative 3 times negative 8 is 24. Negative 30 plus 24 is negative 6. For this function, when f is negative 3, you have a resulting answer of negative 6. Okay, so that's it for module 3.7, but now you see where a lot of the things we're going to use here, particularly this, is going to help us find zeros when we're graphing, which will be next week. And again, we'll do practice on this in class Wednesday and Thursday. Thank you.